Good morning, students. In my last lecture, I have completed exercise 8.3. Now moving to section 8.5 of this trigonometry. So I have told you about this three properties: sine square theta plus cos square theta equal to 1, 1 plus tan square theta equals secant square theta, and cot square theta plus 1 is equal to secant square theta. So directly moving to example number 12. So this example number 12. Directly into number 12. What this says that it says that this express the ratios cos A, tan A, and secant A in terms of sine A. Cos, tan, and secant. This cos A, tan A, and secant A is to express in terms of sine A. Now, the first property, this is, you know that this is sine square A plus cos square A equal to 1. Now you need to express cos in terms of sine. So this is cos square A equal to 1 minus sine square A. So here if you take under root, this cos of A is nothing but under root 1 minus sine square A. This is your expression. How you express this cos A in terms of sine A. This is one. Now second is, I am solving the second part is this tan. So you know that this is tan of A in nothing but, you can write tan A as sine A by cos A. Sine A by cos A. And if you know that this is sine A, the numerator is already in terms of sine and cos A, and you substitute this expression from here to here, so this cos A instead of cos A, I can write it as under root of 1 minus sine square A. So this expression will be my second expression, and which is my second solution. I will write second. The third, I will do it like this. That is third. The third is you need to express secant A in terms of sine. So secant A, secant is nothing but 1 upon cos of A. You know that now you substitute this value of cos from here to here. This is nothing but 1 by under root 1 minus sine square A. Third. This is my third expression, the third answer. So in the 1, 2, 3 I have expressed cos A, tan, and secant A in terms of sine A. This is the answer. So this, if you see that this is nothing, cos of A is 1 minus sine square A. Yes. Tan of A, this is nothing but sine A by under root 1 minus sine square A. And secant A, this is 1 by cos A, which is nothing but 1 by under root 1 minus sine square A. Now, next is 13 is that you prove that secant A into 1 minus sine A is secant A plus and secant A plus tan A equal to 1. So whenever you prove, you need to take LHS and RHS generally separately. So example 13. So example 13 says that this is prove that secant A 1 minus sine A, secant A 1 minus sine A into, this is also into secant A plus tan A. So secant A plus tan A equal to, into prove this is equal to 1. Now let me solve this by LHS and RHS. Taking left hand side equation. So this is nothing but secant A 1 minus sine A into secant A plus tan A. Now you know that this secant of A is nothing but 1 by cos of A, and tan of A, you know that this is nothing but sine A by cos A. So I will substitute this here, which is this. I'm letting this to be, this is cos of A. This is 1 minus sine of A into, in case of secant A, you write this is 1 by cos A. This is plus 1 by, this is sine A by cos A. If you see this, both LCMs are same, so my expression will become 1 by cos of A. This is 1 minus sine A. This will become 1 plus sine A by cos A. Now in numerator I will be solving this much. You can see from this much that this is 1 minus A into 1 plus A. Is nothing but, if you solve uh, this is cos A, I will take combination nothing but 1 by, is 1 by cos square A, and if I say this is 1 square minus sine square A, and this is A minus B into A plus B, nothing but A square minus B square, which implies that this is 1 by cos square A, and you know that this is nothing but 1 minus sine square A. And from property you know that cos square A plus sine square A equal to 1, which implies that cos square A equal to 1 minus sine square A. So you substitute this value here, so what you get is that though your expression that this become 1 plus in place of 1 minus sine square A, you will substitute cos square A, and denominator is already cos square A, so this is already cos square A equal to 1, and RHS also this is 1, so already this is 1. So since your LHS is equal to LHS equal to RHS, hence proved. This is proved. Now what they have done, they are also done the same. They have taken secant A in terms of secant A, they have taken 1 by cos A, and for sine tan A is 1 by sine this. So this question. Now next is prove that cot A minus cos A by cot A plus cos A equal to cosecant A minus 1 by cosecant A plus 1. So example number 14. So this is example 14. It says that this cot A minus cos A, cot A minus cos A by cot A plus cos A equal to cosecant A minus 1, cosecant A minus 1 by cosecant A plus 1, cosecant A plus 1. Now you know that this, what you know that is cot of A is nothing but cos A by sine A. And one more thing you know that that is 1 by sine A equal to cosecant A. So I'm doing LHS, so I'm doing LHS. So this LHS, what in the expression is, that is cot of A minus cos A by cot A plus cos A. So in place of cot I will write cos A by sine A minus cos A by cos A by sine A plus cos A. If I take cos A common from numerator and denominator, this cos A, this is 1 minus sine A minus 1 by, this will become 1 by sine A plus 1, this is cos A. And this cos and this cos A you can cancel, 1. Now you know that this cosecant A, 1 by sine A is nothing but cosecant A from this expression. So if I substitute this value, this my expression will become this. So this cot A minus cos A finally will become cos A, which finally will become this 1 by sine A, this cosecant A. So this cosecant A minus 1 by cosecant A plus 1. And if you, this is my LHS. Now RHS is also same, which is nothing but cosecant A plus 1 by cosecant minus 1. Since LHS, my LHS equal to RHS, hence proved. And what they have done this exactly same thing and show that is equal to RHS, hence they have proved. Now example 15, prove that sine theta minus cos theta plus 1 by sine theta plus cos theta minus 1. They have again given condition using the identity secant square theta equal to 1 plus tan square theta. In this identity you need to do this. So this is example number 15. So example 15 says that you need to prove that your expression sine theta minus cos theta, that is sine theta minus cos theta plus 1 by sine theta cos theta minus 1, sine theta cos theta minus 1 plus cos theta plus equal to 1 by secant theta minus tan theta, secant theta minus tan theta. Using, but they have said you need to use the identity this secant square theta equal to 1 plus tan square theta. Now instead of now doing LHS, I will be first doing RHS. Now my RHS, you know, this is given to me as 1 by secant theta minus tan theta. Then you need to use this property, but you know there is nothing square terms here. So what to do, you need to multiply and divide it by the conjugate terms. So I can write it as 1 by secant theta minus tan theta into this will be, I will multiply and divide by secant theta plus tan theta, and this is also secant theta plus tan theta. So this so which is why my numerator will become the secant theta plus tan theta, and upon in the denominator there is, this is, if you see this clearly, this is secant, the a minus b, this is a plus b, so net it will become the secant square theta minus tan square theta. Now using the property which is given this, if you put value of secant theta here, so nothing but this is secant theta plus tan theta by secant theta, this is 1 plus tan square theta minus tan square theta. So this and this will become cancelled. This is nothing but this is secant theta plus tan theta. This is my RHS. Now I will be doing LHS. So my LHS, I will write it as, my LHS is, this is sine theta minus cos theta plus 1 by, this is plus minus 1. This is sine theta plus cos theta minus 1. This minus 1. Now if you see this expression, if I divide and multiply by, if I take this cos theta as common, then this equation will become, this is nothing but, to take cos theta common, so this cos theta, this is becomes, this is sine theta by cos theta minus, this is become cos theta by cos theta plus this will 1 by cos theta upon, this will become, this I am taking from numerator and denominator both, I am taking cos theta common, this is nothing but sine theta by cos theta minus cos theta, this is plus here, cos theta by cos theta, this is minus 1 by cos theta. And you know that this sine theta by cos theta, already know this is tan theta, and 1 by cos theta, nothing but secant theta. So from here this expression will become, this is cos and cos that cancel, which this is 1, so this will become sine theta by cos theta is tan theta, this will become tan theta minus 1 plus secant theta, and this is nothing but tan theta plus 1 minus secant theta. So if you see this LHS, this is secant theta plus tan theta So if you rewrite this expression, this I can write it as, this as to be equal to, this is tan theta. There is no denominator, so I need to remove this. My denominator, I need to remove this. So this is tan theta plus secant theta minus 1, and this is my original. This is tan theta minus secant theta. I'm trying to write this like this. I will write it like this. This is tan theta plus 1 minus secant theta. Now if you see this, and I will multiply and divide by conjugate of this. This is nothing but tan of theta plus 1 minus, in place this is minus, so I will write it plus theta, and since I am multiplying the numerator, I will divide the same thing by denominator. My main purpose is to get rid of this denominator. This will be secant theta. If I do this, so in numerator you can see that this is tan theta plus secant theta whole square minus 1 square. See that this and this you can take from to be at one side, and this is plus 1 and this is minus 1 here. So this is like this, and upon denominator you can see that this is tan theta plus 1 whole square minus secant square theta. So if I expand this, this is tan square theta plus secant square theta is plus 2 tan theta secant theta minus 1 upon, this is tan square theta plus 1, this is square whole, so this is tan square theta plus 1 plus 2 tan theta minus secant square theta. Now you know that this secant square theta equal to 1 plus tan square theta. So using this, that your numerator will become that this is tan square theta plus, see this secant square theta minus 1, the secant square theta minus 1 become tan theta, so tan square theta. So this is my tan, again my secant square theta minus 1 become tan square theta plus 2 tan theta cos theta, and upon this is tan square theta plus 1 is already, you know, this is secant square theta, so the plus 2 tan theta minus secant square theta. So this secant square theta will get cancelled. So this is different. This is formula. So in numerator, my numerator will become 2. I will take 2 and tan theta as common. 2 and tan theta. So I will take 2 tan square theta plus 2 tan theta secant theta upon, this will be 2 tan theta. If you divide this, if I write it individually, this will become, this is 2 tan square theta by 2 tan theta plus 2 tan theta secant theta by 2 tan theta. Now if I cancel this, so this 2 and 2 get cancelled, this 2 also, this 2 get cancelled, this tan theta and from this 2 get cancelled, there will be 1 tan theta here, then tan theta gets cancelled. So my present expression will become this tan theta plus, there is 1 left is secant theta. Now you can see that my LHS is equal to RHS. Since my LHS is equal to RHS, hence proved. This is my LHS, and from above it, you can see that this was my RHS, and so this my LHS is equal to RHS, hence proved. So my next is they are let's just see that they have also done the same thing, this minus and tan theta and this, and later they have proved that this is, but they have done some different tricks. But the final thing is that you need to prove that LHS is equal to RHS. Now jumping to exercise 8.4, question number 1 says that express the trigonometric ratio sin A, secant A and tan A in terms of cot A. So 8.4, exercise 8.4. So exercise, no, do not exercise, example 8. This is exercise 8.4. So this is exercise 8.4. So, and this is question number 1. You need to do what? Do this is do sine A, secant, and tan A. Sine A, secant A, and tan A. Do that is expressed in terms of cot A. Cot A. Now, cot A. So you know that this cot square A plus 1 equal to secant, equal to cosecant square A. Now if you see this, which implies that this cot square A plus 1 under root is equal to cosecant A. Yes, and you know that cosecant A is equal to 1 by sine A. So if I write this, that if I this cosecant A equal to under root of this cot square A plus 1, and if I in place of cosecant A, I will write this 1 by sine A. 1 by sine A is under root of cot square A plus 1. So which implies that my sine A equals 1 by under root 1 plus cot square A. This is my first expression. Now second, I need to write it as secant A. So secant A is nothing but 1 by cos A. And you know that 1 by cos, you know that by this is cos square A plus sine square A equals 1, which implies that the cos of A is nothing but under root of 1 minus sine square A. So I can write it that this is under root of 1 minus sine square A, which is nothing but this is 1 by under root of this is 1 minus, so I substitute this value of here. This is nothing but 1 by 1 under root 1 plus cot square A. So if I simplify is numerator in terms of numerator and denominator, so this my expression will become that this is secant A will finally become that this is nothing but 1 by under root of 1 minus, this will be 1, this root will get cancelled from square, so this is 1 plus cot square A. It's nothing but if I rewrite this as this is 1 by, I take the LCM, and so this the root of this numerator denominator comes this up above, this is 1 plus cot square A and upon this is, if you see, this is nothing, this is 1, I have taken LCM, I have taken this is 1 plus cot square A minus 1, nothing but this will be my this will be my under root of 1 plus cot square A by this 1 and this 1 minus 1 that cancel, so under root of cot square A, nothing but under root of 1 plus cot square A by under root and the square will get cancelled, this is cot A, which is my secant of A. Secant of A is under root 1 plus cot square A by cot A. So this will be my second expression. Now third is you need to express tan. This tan in terms of cot. So you can know that this tan A is nothing but 1 by cot A, directly expressed. So next is my expression. There's exercise question 2. Write all trigonometric ratios of angle A in terms of secant A. Terms of secant A. Now you know that the sine A is nothing but under root 1 minus cos square A as 1 plus, sorry, as sine square A plus cos square A equal to 1. Know this, from this you derive this. So And also you know that this cos A equal to 1 by secant A. Which implies as sin A can be written as this is under root of 1 minus, because of course I will write secant. So this is 1 by secant square A. This is nothing but if we take the LCM, this is secant square A minus 1 under root by under root secant square A, nothing but this is under secant square A minus 1 by this is under root and square root cancel, this is secant A. This is my sine of A. And if you already know that this cos of A is nothing but 1 by secant A. This is inverse, so this is directly, this is 1, this is 2. You know that there are 6 trigonometries in this: sine, cos, tan, cot, cosecant, and sec. Secant is already given, so I have 5 expressions, or 2 expressions I'm already having. Now, what is my tan A? Tan A is nothing but from 1 and 2, you know that this is tan is nothing but sine A by cos A. So if I from 1 and 2, you get that this is nothing but under root of secant square A minus 1 by secant A divided by cos A. Cos A is nothing but 1 by secant A. And if you express this is nothing but secant square A minus 1. A minus 1 under root. Now this is my third expression. So I'm writing this to be my third expression. Now next is tan, sine cos tan, and next is cosecant. Cosecant A, you already know this is 1 by sine A. So from 1 only you get that this is inverse of this is nothing but secant A by under root secant square A minus 1. This is my fourth equation, and my fifth equation will be, this is secant A, sorry, this is secant A, now this is cot A, and you know that cot A is nothing but 1 by tan A. So this will my inverse of this is equation number 3, so this is nothing but 1 by under root secant square A minus 1. This is my fifth equation, and this is my total. So I have expressed all in terms of all parameters which use in terms of secant A. Now next is next expression is third question number third first. Evaluate this upon this. So evaluate, I am writing third first part. This is sine square 63 sine square 27 sine 63 degree plus sine square 27 degree by cos 17 cos 73 cos 17 square 17 degree plus cos 17 square is cos square 73 degree. 73 degree. Now if you clearly see that this 63 plus 7, sorry, this is 27. So this is 63 plus 27 is nothing but 90 degree. And from here you can see that this is 73 and 17. This 73 plus 17 is nothing but 90 degree. So you can convert any one of these two sine, and other will be remaining cos. So from here you get that this numerator will become, this is sine square 63 degree, nothing but this, you can write it as cos square 90 minus 27 degree. It is nothing but this, I am taking this to be cos square 17 degree plus, in place of cos I will write sine square, the 73 is 90 minus 73 degree. Well, this is nothing but this is sine square 63 degree plus this is 90 minus 27 is 63, so this is cos square 63 degree by sorry for disturbance. So this will my sine is this, and now this will be with cos square 17 degree plus this is by sine square, this is sine square, this is 90 by 73 is 17 degree. 17 degree. Now you one property know that this is that cos square theta plus sine square theta equal to 1. And from this you can this is sine square theta by plus cos square theta, because theta is same, and denominator also you know this is cos square theta plus sine square theta. So this whole expression will become 1 by 1, which is nothing but 1. So my expression 1 for first is 1 answer. 1 is my answer. Now for second, this is sine 25 cos 65. Sine 25 degree cos 65 degree plus cos 25 sine 65. Cos 25 sine 65. You know from this that this cos 25 and sine 6 this, and if it is to this 25 degree plus this 65 degree, if you add this is 90 degree. It's become 90 degree. So you can convert any one into two. So this I will this sine place of sine I will write cos of 90 minus 25 degree. And this is already cos 65 degree. And in place of 25, this is 25 65. So I will again write this cos into sine, and this line sine of 25 is nothing but 90 minus 25 degree. I am writing in only 1 degree angles. So this is my sine 65. I will remain 65. So if you get down to this final expression, this is nothing cos of 90 minus 25 is 65 degree into cos of 65 degree plus this is sine of 90 minus 25 sine of 65 degree. So this is sine of 65 degree into sine of 65 degree. If you see that these angles are same, cos cos the sine sine, so this expression will become this is cos of 65 degree plus sine of square 65 degree. Now you know that cos square theta plus sine square theta equal to 1, which implies this expression becomes 1, and 1 is your answer. So first and second both answers are 1. Now if you see the question number 4, you need to choose the correct option and justify your answer. Justify answer. This is 9 secant square a minus 9 tan square a equal to. So for fourth first part, so 9 secant square a minus 9 tan square a is equal to nothing. If you take 9 common, this is secant square a minus tan square a, and you know that secant square a equal to 1 plus tan square a, and from here this secant square a minus tan square a is nothing but 1. So if you substitute value here, this the expression will become 9 into 1, which is nothing but 9. So 9 is your answer, and the option 9 is B. So correct answer is B. Now next is I'm writing second. Second is this expression is 1 plus tan theta plus secant theta. 1 plus tan theta plus secant theta into 1 plus cos theta minus cosecant theta. If you clearly look at this, this is write this is sorry, this is not third. This is, if you write this is tan theta is this is sin theta by cos theta, and 1 by secant theta is 1 by cos theta, and from here this is, if you write this as this is 1 plus cos theta is cos theta by sin theta, and minus 1 by cosecant theta, cosecant theta 1 by sin theta. So if you express take LCM here as cos theta, and if I take LCM as sin theta, so this expression will become this is cos theta plus this is sin theta plus 1 by cos theta, and here if you take sin theta as your common base, so this will become this sin theta plus cos theta minus 1 by this is sin theta. Now if you solve further, you can see that this is, if I take this sin theta as my first sin theta plus cos theta, if I'm making as group This is cos theta plus sin theta, and this is cos theta plus sin theta. There is minus plus 1 here, and this is minus 1. If you multiply, this is a plus b and into a minus b. This is nothing but a square minus b square. So I can write as that cos theta. This is cos theta plus, sorry, my sin theta. So this is my cos theta plus sin theta. I will take it. This is square minus 1 square by cos theta into sin is cos theta into sin theta. From here you can this is a square. The a plus b whole square is nothing but a square plus b square plus 2 into a into b cos theta minus 1 upon cos theta into sin theta. Now you know that this expression cos square theta plus sin square theta, you already know this is 1. So you can write it as this is 1 plus 2 sin theta into cos theta minus 1 by cos theta sin theta. So 1 and 1 get, this is minus 1, this is plus 1 minus 1 get cancelled, and so this expression will become this is 2 sin theta cos theta upon sin theta cos theta. The sin theta sin cos theta, this can the expression answer is 2. And if you see this option 2 is C, so you C is your correct answer. So C is your correct answer. Next question is if third is that secant theta plus tan theta into 1 minus sin theta. So secant theta plus tan theta 1 minus sin theta sin a, sorry, sin a, this is going to be sin a to express. So this is a, this is tan of a. So if I express this is my third part, third. So if I can write the secant a is 1 by cos a, and tan is, you already know, this is sin a by cos a, and this is 1 minus sin of a. And if I take LCM of first equation, this whole expression will become 1 plus sin a into this 1 minus sin a by this is cos square a. So if you see that this is a minus b, this is a plus b, this is a minus b, so multiplication will be a square minus sin square a by cos square a. So this whole expression will become, you know that you already know that is cos square a plus sin square a equal to 1, which implies that cos square a is nothing 1 minus sin square a. So this 1 minus sin square a is nothing but cos square a. Upon there is also cos square a, so if this is cancelled, this answer is 1. So answer 1 is, sorry, not 1, there is a denominator cos a, and there is cos a, but this is not cos square a, this is cos a. So this is cos a and this is cos, so this become expression becomes not 1. This expression will be is cos square a by cos a, nothing but if this power 1 power get deducted, so this will be cos of a. Cos of a is your answer, and cos of a is option D, so option D is correct. Option D is correct. So the next part is fourth, 1 plus tan square a by 1 plus cot square a. Secant square a and this cot square a. It is 1 plus tan square a by 1 plus cot square a. And by the formula, you know that 1 plus tan square is secant square a, and 1 plus cot square a is cosecant square a. And you know that secant square a is 1 by secant a is 1 by cos a. So this is from cos square this, and divided by cosecant a is 1 by sin square a. Nothing but this sin square a. I will divide this, become this sin square a by cos square a, and you know that sin a by cos a is tan a. So this become tan a whole power 2. Nothing but tan square a. Tan square a. So if you see that this is tan square a, this is option number D. So your option number D is correct. Option D is correct. Your answer. And the fifth question is fifth, there are many questions. Prove the following identities where angles involved are acute angles for which the expression are defined. We already find that these are valid for the acute angle. So fifth, question number fifth, part number question number fifth, part number one. This is cosecant theta minus cot theta. This cosecant theta minus cot theta whole square is nothing but it is given that this we to prove that this is 1 minus cos theta. This is 1 plus cos theta. 1 minus cos theta and this is 1 plus cos theta. And if I take this is to do by method of LHS, RHS, LHS is this cosecant square theta minus cot square theta. Sorry, this is not this is, nothing. This is whole square. Sorry, this is whole square. Not this cosecant, this whole square. Whole square. So if you see this, this is you know that this cosecant is 1 by sin theta. Cosecant theta is 1 by sin theta. This cot theta is nothing but this is nothing but cos theta by sin theta. So the square. So this is 1 minus cos theta whole square, and this is nothing but this is sin square theta. And you sin square theta. You know that sin square theta plus cos square theta equal to 1. From here you know that is sin square theta equal to 1 minus cos square theta. You substitute this value here and this value here, so the my expression will finally turn out to be this is 1 minus cos theta whole square by sin square theta you need to 1 minus cos square theta. And if you know if you see this expression clearly, this is 1 minus cos square theta is this is 1 minus cos theta. This is 1 plus cos theta. This is a square minus b square is a minus b square plus b. Now we get 1 minus cos theta and this 1 power will get cancelled. So this expression will become 1 minus cos theta by 1 plus cos theta. So which is your RHS. You can see that this is your RHS. Hence proved. Hence proved. Now second expression is oh my god, I think I will take second is second expression is cos A by 1 plus sin A, cos A by 1 minus sin A plus 1 plus sin A cos A, 1 plus sin A cos A equal to prove that is equal to 2 secant A, 2 secant A. We need to prove that this is 2 secant A. Now from here if you take the LCM, which implies that I'm taking LHS and taking LCM, so this is become cos A into cos A. This will become this becomes 1 plus sin A into 1 minus sin A. Nothing but is not equal to and this upon in denominator I have taken LCM. So this is my 1 minus sin A into cos A. If this is cos A into cos is cos square A. You see that this is 1 plus sin, this is 1 plus minus sin A. So this is nothing but 1 square minus sin square A. And you know that this 1 minus sin square A is nothing but cos square A. Minus sin A is cos A. And you know that this 1 minus sin square A is nothing but cos square A. So I can write it that this is cos square A plus of cos square A upon 1 minus sin A into cos A. So if you go like this, this is cos square A 1 plus 1 minus sin square A, 1 minus sin square is cos square A and is cos square A only. So this is 1 minus sin. Okay, so this is 2 cosecant A. This is cosine beta. So this is 1 plus sign, not minus sign. This is 1 plus sign. So this is 1 plus sign. So this nothing but this is 1 plus sign. 1 plus sign. So this expression will not be there. Instead, this is 1 plus sine square, and this term will be 1 plus sine a whole square, and this will be the expression will be this is cos square a plus a square a plus b equals 1 is a square plus b square plus 2 into sine a by 1 plus sine a into cos a cos of it. Now if you see this clearly, see 1 plus sine is there, is a sine square a, this 2 sine a, 1 plus sine a, and if you see this is sine a. So this cos square, this is cos square a plus sine square a, this becomes 1. So I can write this expression, and this is 1 plus 1 plus this is 2 sine a. This 1 is for this 2 cos square a plus sine square a becomes 1, and this 1 is for this one, and upon my denominator is still 1 plus sine a by cos of a. Now this 1 plus 1 is 2, so this 2 I will take common, this is 2, 1 plus sine a, and if I take that to be denominator, this is 1 plus sine a, this is cos a. 1 plus sine 1 plus sine gets in, and you know that this is 1 plus cos a, nothing but secant a, which is nothing but 2 into secant a. This is my RHS. Since L is equal to RHS, hence proved. Now the next is my third part. Is now the third expression. Third expression is tan theta by 1 minus cot theta. So this third will be, tan theta by 1 minus cot theta, and is plus cot theta by 1 minus tan theta, and is equal to 1 plus secant theta. Write the expression in terms of sin theta and cos theta. Okay. So this is, you need to put that this is equal to 1 plus secant theta, 1 plus secant theta cos secant theta. The bracket, it is given that hint, write the expression. This is a hint. You need not to write in sin and cos theta. This is a hint. It is given. Tan theta by 1 minus cot theta equal cos theta minus tan theta. Now you know that this cot theta equal to 1 by tan theta. You know that's this. So if I substitute this, which implies that I'm taking LHS, this is tan theta. By only I'm doing with this with LHS. This tan theta, this is, I can write it as 1 by tan theta plus this is my cot theta, and I will still write it as cot theta only, and this is 1 minus tan theta, and from here this is equal to, I take this tan theta in my LCM, so this LCM, this denominator expression will be, come to numerator, this tan square theta, this is tan theta minus 1 plus this is can be written as cot of theta by 1 minus tan theta. So I can take LCM as 1 minus tan theta. When I take 1 minus tan theta is minus 1, this is 1 minus tan square theta, and this is cot theta. Now in place of cot, I will be taking cot theta out. So this I am taking cot theta to be out. This expression will become minus tan square theta by cot theta plus 1 by 1 minus tan theta. Now you know that already know that 1 by cot theta is nothing but this is tan theta. So which implies that this is nothing, this expression, this cot theta will remain like this, and this 1 by cot theta minus solution minus tan cube theta plus 1 by this is 1 minus tan theta, and you can rewrite it to be as this cot theta is 1 minus tan cube theta by 1 minus tan theta. And you know this 1 cube is 1, so I can write this 1 as 1 cube. Now you know that this a cube minus b cube nothing but this is a minus b, this is a square plus b square plus ab. This one, am I right? I'm checking this, that this is a minus b whole cube, nothing but this is a cube minus b cube plus this is sorry minus 3a square b plus 3ab square. This is nothing but minus, if I take minus 3ab, this is a minus b, this is a cube minus b cube. I take this here, this is a minus b, a square plus b square minus 2ab plus 3ab plus ab. Yes, I'm correct. I'm right. This one is my correct formula. So if I write this one, write as 1 cube minus t cube, I can write expression is that this is cot theta, and 1 cube minus t cube I can write it as 1 minus tan theta into 1 square is 1 only, so this is tan square theta plus tan theta. I can write it as this upon 1 minus tan theta. Right. You have to know that this 1 minus tan theta and 1 minus tan theta is cancelled, this is 1, and this cot theta like taken inside the bracket, that this is another cot theta into 1 is cot theta plus cot theta into tan. So this cot theta and tan theta, one you know that this cot theta equal to 1 by tan theta, which implies that tan theta into cot theta equal to 1. Now I'm multiplying cot theta and tan theta, so I will be cancelling 1 theta out directly. So I can write this tan, this I can write that tan theta, because cot theta into tan square theta, 1 cot theta and 1 tan theta will make it 1, and only tan theta will remain. So this cot theta plus tan theta is 1. Now what is given the question is, this is equal to 1 plus secant theta cosecant theta plus secant theta into this. Now you can write this as, if you, this is 1 plus this is tan theta plus cot theta, and you know that this is nothing but this is tan theta, and you can write cot theta 1 by tan theta, nothing but 1 plus I'm taking just tan square theta, tan theta LCM for this 2 equation, so this will become tan square theta plus 1. So you know that tan square theta plus 1 is secant square theta. So this expression 1 plus numerator will become secant theta. This is 1 secant square theta. You know that this 1 by cot theta is 1 by tan theta. 1 by tan theta nothing but 1 plus secant square theta into cot theta. What is my expression in secant into cosecant theta? Secant into cosecant theta. Okay. So you know that this cot theta also, this is cos theta by sin theta, and also this cosec theta is written 1 by sec theta, so this is sec theta into cosecant theta. So putting this value of cot theta of cosecant theta upon cot theta here, you get the expression that this is equal to 1 plus secant square theta, and in place of cot theta I will write cosecant theta by secant theta. So 1 secant theta and 1 secant square theta, which cancel, this will become 1 plus secant theta into cosecant theta, which is equal to RHS. Hence proved. The third is over. The fourth, they have also given the fourth, and they have also given a hint that simplify LHS and RHS separately. Simplify LHS and RHS separate. So you may not do this. So up to you only. So this fourth question is like fourth part, not question. Fourth part is 1 plus secant A by secant A equal to sine square A by 1 minus cos A. Now I'm taking LHS. See, there's 1 minus cos A, there is secant A. This will never be possible if unless until I multiply and divide by secant and secant A. So LHS, what I will be doing is I will be writing this secant A. So I will be writing a, since there is 1 minus, so I can write it 1 by secant A. Numerator is already secant A, denominator already there is secant A, and I am multiplying dividing by 1 minus secant A. Well, else you can do one more thing, that you need to make it cos. So you do this secant A. What to do is that you directly like this one. This is secant A. You know that is secant A is nothing but 1 by cos A. 1 by cos A you already know. So this I can write as 1 plus 1 by cos A, and this is 1 by cos A. And if you know, this is nothing but this will become cos A plus 1, and this will be upon this will be this by cos A into cos A. Cos A gets cancelled, is 1 plus cos A. Now 1 plus cos A, you know that this is 1 plus cos A. You can multiply and divide by 1 minus sine is 1 minus cos A. You can multiply and divide minus cos A. So in the numerator there is 1 A plus B, and this is A minus B. So this is A square minus B. So this is 1 square minus cos square A by 1 minus cos A. And you know that this sine square A plus cos square A equal to 1, which implies that this 1 minus cos square A equal to sine square A. And if I put this value here, it's nothing but 1 minus cos square A, 1 minus cos square A by 1 minus cos A. Nothing but 1 minus cos square A is sine square A by 1 minus cos A. Nothing but is RHS. Then L is equal to RHS, hence proved. So even without solving individually, I have proved this. So fifth is this is given that you need to use the identity cos square A equal to 1 plus cot square A. So what is my LHS? LHS is given to be cos A minus sine A. Cos A minus sine A plus 1 by cos A plus sine is minus 1. Is cos A plus sine A minus 1. Cosecant cot. Now if you need to prove this is equal to cosecant A cot A, cosecant A plus cot A. Now you know that you first take cos A as common from both numerator and denominator. We take cos A, this is I'm solving for LHS. It's cosecant A, and this is cosecant A have taken, this is 1 minus, this is sine, so this is sine A by cos A plus 1 by cos of A. So not cos A, you need to take sine as common. I'm taking sine A. And if we take sine, because there is a cosecant term here, and to take sine A common. So this sine A, I'm taking sine A to the common, which implies this is cos A by sine A, and this is nothing but sine A by sine A plus 1 by sine A, and divided by, since this is also numerator I'm taking sine A common, and denominator also I'm taking sine A common. So this cos A by sine A plus sine A by sine A minus 1 by sine of A. So if you open this you know that this cos A by sine A, you already know this is 1. This is cot of A, and this 1 by sine A is cosecant A. So if you write this expression will become the sine A that cancels 1, and cos A by sine A, you can write it as cot A minus cos sine A by sine A is 1, and this plus 1 by cosine is cosecant A. This upon this is cot A plus 1 minus cosecant A. Cot A plus 1 minus cosecant A. Now if you multiply and divide this expression by this is cot of A, this is my original expression. This is, and say this is cosecant A. If you multiply divided by this is cot A plus 1 plus cosecant A, and this by cot A plus 1. So same, since you are multiplying and to divide by same. Now from here you can see that this is by A, this is A minus B, A plus B. So you can write it as, in numerator you need to say that this cosecant A and cot A, I will make it as A, this cosecant A, cot A will make A, and this minus is here and there is plus here. So for this another expression will be, your expression will become numerator, it is like cot of A plus cosecant of A whole square minus 1 square, and in the denominator your expression will become this cot of A plus 1 whole square minus cosecant square A. And from here it is, this is A plus B whole square is cot square A plus cosecant square A plus 2 cot A cosecant A minus 1 upon, this is cot square A plus 1 plus 2 cot A minus cosecant square A. And you know that this cot square A plus 1 is nothing but cosecant square A, and this cosecant square A and this cosecant square gets cancelled, and you know that this cosecant square A and minus 1 is cot square A, and there is already cot square A, so this will become, does not cancel, this will become 2 cot square A, this cot square A and 1 cot square A for this, and this plus 2 cot A cosecant A upon 2 cot A. We divide by 2 cot A, so this 2 cot A will become this, write it individually, that is individually this will become, sorry, this will become 2 cot square A by 2 cot A plus 2 cot A cosecant A by 2 cot A. If you see that this is 2 cot A and 2 cot A is cancelled, this 2 cot A and 2 this, and this cot square, so this cot A will remain. So this ultimately equal to cot of A plus 2 into this is 2 also gets cancelled from me. This is cosecant of A. So nothing but this is RHS. We will equal to RHS, hence proved. This question also proved. Now next is your you have used the property cosecant square A equal to 1 plus cot square A property you have used, and using this property you have proved. So next is sixth part. What is sixth part? It is seems to be tough, but it is not a tough question. Need to just, so this is under root 1 plus sine A by under 1 minus sine A. So if you do the next part is sixth part. So sixth part is under root 1 plus sine a. You need to prove that is under root, so this is 1 minus sine of a equal to secant a plus tan a. Secant a plus tan a. Secant of a plus tangent of a. So this expression I am taking LHS first. LHS, this is 1 plus sine a by 1 minus sine a. So can you do anything for this expression? So I cannot do anything. I'm helpless and hopeless. No, never become hopeless. So directly you cannot do, but indirectly you have 1. So this is 1 minus sine a, and you can see this denominator you are having 1 minus sine a. So I'm taking conjugate of this and multiplying, dividing. So this is 1 plus sine a into 1 plus sine a. Now if you expand this, and in numerator you will have 1 plus sine a whole square, and in denominator you will having 1 minus sine square a. And you know that 1 minus sine square a is cos square a. So you can write it as under root of 1 plus sine a by cos a whole of the square. This square root and square get cancelled, so the expression will ultimately be this is 1 plus sine a by cos a. And if you individually write, this is 1 by cos a plus this is sine a by cos a. And you know that sine a by cos a is tan a, and 1 by cos a is secant a. So this will become secant a plus 1 by tan a is 1 by sine a by cos a is tan a. So secant a plus tan a, which is nothing but this is RHS. Since LHS is equal to RHS, hence proof. Now seventh question, seventh part is that sine theta minus 2 sine cube theta by 2 cos cube theta minus cos theta is ultimately tan theta. So how will you prove this? So you are writing your seventh part is seventh part. I'm rewriting as this is sine of theta minus 2 sine cube theta by 2 cos cube theta. 2 cos cube theta minus cos theta is equal to tan theta. You prove that this is equal to tan theta. Is equal to tan theta. So I'm writing this LHS here. LHS I'm writing. So LHS is that this is sine theta minus 2 sine cube theta by 2 cos cube theta minus cos theta. If I take sine theta to be common from numerator, and from denominator I'm taking cos theta as common, this whole expression will change to this is sine theta. I'm taking this 1 minus 2 sine square theta by I'm taking cos theta as common, so this will become nothing but this is 2 cos square theta minus 1. 2 cos square theta minus 1. Theta minus 1. So if you see this, this is you know that sine square theta plus cos square theta is square here, no, theta equal to 1, and 1 I am substituting this value as here and here. So my internal expression, this is sine theta by cos theta, you already know this is tan theta. So this is tan theta is outside the bracket, and 1 I can write that this is sine square theta plus cos square theta minus 2 sine square theta by this is 2 cos square theta minus of this is will be sine square theta plus cos square theta. If you rewrite this expression, this expression will be nothing but this is tan of theta, and this is sine square theta minus 2 sine square. This is cos square theta minus sine square theta upon see this is 2 cos square theta minus sine square theta minus cos square theta. So from 1 cos square theta will get cancelled in denominator from cos square theta in negative value. So this is cos square theta minus sine square theta upon this is 2 minus 1 is 1, so this is cos square theta minus sine square theta. If you see this numerator and denominator, this will just cancel to 1, and there's tan theta, this will become tan theta, nothing but RHS. Now since LHS is equal to RHS, hence put. So seventh is also done. What is my eighth expression? It is, you see that this is a tough question, but this is not a tough question. It is a much easier question. So if you do this eighth question, this is seventh I've done, this is eighth question. So what is my eighth question? I need to write. I am getting bored with this black, so I'm writing eighth. So my eighth question is, this is cos sine cosecant, sine cosecant cos secant, sine cosecant plus cos secant. Before that, this is 7 plus, what is the 7 plus tan square a plus cot square a, tan square a plus cot square a. We need to prove this. So I am taking this LHS. I'm very interested in LHS. This is sine a plus cosecant a whole square plus cos tangent a plus secant a whole square. So if you expand a plus b square, this is nothing but this is sine square a plus cosecant square a plus is 2 sine a into cosecant a. This is my first expansion of my bracket. This is cos square a plus secant square a, and this is plus 2 cos a secant a. Now you know that sine a equal to 1 by cosecant a. From here you know that sine a into cosecant a equal to 1, and also cos a equal to 1 by secant a, which implies that cos of a into secant of a equal to 1. And if you see this, if I substitute this value, sine a value as 1 here, and if I substitute this value as here, so my entire expression will change to this is nothing but this is sine square a plus cosecant square a plus this is 2 into 1 plus this is my cos square a plus secant square a plus 2 into 1. So now you know that, now you can see that this sine square a plus cos square a is 1 into 1. This is 2 and this is 2, and you also know that this cosecant, you also know that cosecant square a is equal to 1 plus cot square a, and this secant square a is equal to 1 plus tan square a. So substituting these values, so that's my expression will become sine square plus cos square will become 1 plus, in place of this is my 1 plus cot square a, this is by 2 plus cos square a already I have taken is 1, and this is secant square is nothing but 1 plus tan square a, and this is nothing but this is plus 2. And if you see this is 2 plus 1 3 plus 2, this is 5 plus 1 6 plus 1 7, therefore this is 7 plus this is cot square a plus tan square a, nothing but is my RHS. Now since LHS is equal to RHS, hence proved. Now what is my ninth? It is giving hint that simplify LHS and RHS separately. Simplify LHS and RHS separately. It depends on you whether you want to solve separately, or it is easier for you to solve just LHS and get the value of RHS from LHS. So this is my ninth part. Ninth part is cosecant A minus sine A is cosecant A minus sine A into uh, secant A minus cos A. Secant A minus cos A equal to, saying that you need to prove this is 1 by tan A plus cot A. 1 by tan A plus cot A. Cot A. So there is nothing good in this expression. Uh, you know that that this is sine cos secant. So 1 by sorry, you know that this sine, you know that this sine of A is 1 by cosecant A. It implies that cosecant A is 1 by sine A, and similarly secant A is also 1 by cos of A. You substitute this value, so this your expression will become, this cosecant A will be 1 by sine A minus sine A into, this is cosecant is 1 by cos A minus cos A. If you simplify this, you take LCM of sine A and cos A in their respective brackets. So your expression will become, this is 1 minus sine square A by sine A into 1 minus cos square A by cos A. Now if you know that sine square A plus cos square A equal to 1, and from here you know that this is 1 minus sine square A equal to cos square A, and similarly from this is 1 by cos square A equal to sine square A. So if you substitute this expression here, so this my 1 minus sine square will become cos square A by sine A into this 1 minus cos square A becomes sine square A by cos A. So ultimately this will become my cos by sine is cot A, and 1 cos A will remain, and from this sine by cos, one there is 2 sine, so 1 sine by cos is tan A. So this is my tan A, this will be my sine A. Oh sorry, sorry, not need to write this. Sorry. Directly can do that, this from that. It was just this one sine A and one sine A. This cos A, cos A become cancel. This is ultimately become sine A into cos of A. Cosecant A minus sine A, secant A minus cos A, 1 by tan, 1 by tan A plus cot A. So if you do that, this like this multiple line divided with cot A plus tan A. Do like this, multiply and divided by cot A plus tan A is already given the expression. You don't need to be see the future, but you need to just get to the answer, which is nothing but this. If you take the numerator and multiply, this is nothing but sine A into cos A into cot A plus, this is sine A into cos A into tan of A by cot A plus tan A. So from here, this is cos of A and cot of A. cot A is this, and you know that this cot A is nothing but cot of A is nothing but cos A by sine A. So from here you can write it as cos A by sine A, and here is tan A is nothing but sine A by cos A. And if you guys see that this cos A and this cos A gets cancelled, and here this is sine in denominator, sine A and sine A is cancelled. This is cos A into cos A, this is nothing but cos square A plus, and this is sine A and sine A here, so this is sine square A by cot A plus tan A. And you know that cos square plus sine square is 1. The sine square plus cos square theta is 1. So this is 1 by cot A plus tan A, which is equal to RHS. Now since LHS equal this is RHS, then also RHS, hence proved. Hence proved. So my ninth, I have solved this ninth also. Now the last is 10th. You prove triplet value. So this is triplet value. You solve separately for 1 and 2. So this is 10th question, this is final, and this is like 1 plus tan squared theta. So this is 1 plus tan squared A by 1 plus cot square A. The cot square A, this cot square A is, you need to prove that this is nothing but equal, sorry, equal to uh, is equal to 1 minus tan A, 1 minus tan A by 1 minus cot A whole square equal to nothing but this is tan square A, tan square. Now here I am solving this function. I cannot write LHS answer because there is 3 values. So first this is 1 plus tan square, you know that this is secant square A by 1 plus cot is cosecant square A. So you know that this tan theta is nothing but sine theta by cos theta, and you know that sine theta is 1 by cosecant theta, and cos theta is 1 by sec theta, so the sec theta will become denominator. So secant theta by cosecant theta is tan theta. This is secant theta by cosecant theta is nothing. I can write from here, this is, I can write, I know this from there, I can write it as secant A by cos, it's cosecant A whole square is nothing but this is tan A whole square is nothing but tan square A. So I have proved that one value, I have proved that this is equal to this. Now second, I need to prove this, for I am solving this here. Solving this is 1 minus tan A by 1 minus cot A. You know that this cot A is nothing but cot A is 1 by tan A. So I'm substituting this in the denominator, this whole square. So 1 minus tan of A by, this is 1 minus 1 by tan A whole square is nothing but this is, if I write this directly here, this is uh, mm, nothing but this is 1 minus tan of A, and if I take tan of A minus 1, and 1 tan A is in denominator, this whole square. Now if I take, now if you see this, that you must be knowing that is 1 minus AB whole square is nothing but B minus A whole square. Same, this is one and same thing. This is A minus B, and this is A minus B, and this is B minus A whole square. This will cancel, this is 1, because this is square is there in the power terms. Or even if you don't want to cancel this, you write that this is nothing but this is minus 1. This is minus 1 by tan of A, sorry, this is 1 by 1 of tan of A. This is 1 by 1 of tan of A is nothing but minus tan A. This is whole square. This is whole square of minus tan A whole square. This is nothing but tan square A. Now since I have proved that both the terms tan A and tan A this are equal, so this I have solved the question number 10. Now what is the summary? The summary is simple, that I have told you sine A is Side opposite to angle A upon hypotenuse is perpendicular by hypotenuse, and cos A is side adjacent to base upon hypotenuse, and tan is this side opposite upon tan. This is perpendicular by hypotenuse. This is perpendicular by base. Cosecant is my sine A, cosecant is my cos A, and tan is my cot, and tan A is also sine A by cos A. I've told you this that if one of the trigonometric third is one of the trigonometric ratio of acute angle known, the remaining trigonometric angle is easily determined. I also shown this just simple. This is given the question only. The value of trigonometric angles of 0, 30, 40, 60, and 45, 60, and 90. So this is cos 0. I find the cos 0, cos 30, cos 45, cos 60, and cos 90, and so the value will be 1, and this will be root 3 by 2, and this will be 1 by root 2, and this is 1 by half, and this is 0 for cos. And for sine, the sine 0, sine 30, sine 45, sine 60, sine 90. So the sine 0 will 0, 30 will be half, 45 1 by root 2, 60 is root 3 by 2, and sine 90 is 1. Now if you simply do for tan, the tan 0 is 0, tan 30 is 1 by root 3, tan 45 is 1, tan 60 is root 3, and tan 90 is infinity. This is not defined. And inverse of all this will be your sine inverse will be cosecant, cos inverse will be secant, and tan will be inverse will be tangent will be cotangent cot. Now fifth is the value of sine A cos A never exceed 1. You know that you have seen that the sine A and cos A remain between 0 to 1, whereas secant and cosecant A will be always be greater than or equal to 1, because the minimum value this is inverse of this sign. So if 1 by 1 is minimum value is 1, and 1 by d is undefined, so this will lie between 1 to infinity. Now you also know that this sine of 90 minus a is cos A, and cos of 90 minus is sine A, and this sine of 90 minus a is cot A, and cot of 90 minus a is tan A. Also secant A 90 minus a is cosecant A, cosecant 90 minus a is secant A. So 6 is also proved. Now 7th is sine square A plus cos square A is 1. This is sine square theta plus cos square is 1, and sine square theta minus tan square theta equal to 1 for A less than equal to 90 degree, and cosecant square theta equal to 1 plus cos square theta valid 1 for A is less than equal to 0 to 90 degree. This is valid. So I have solved you this. Thank you for listening to me patiently. I'm ready for my next lecture. I will be taking another part of trigonometry.